All right, back for number 9 on section 5.4, or maybe not back. Maybe this is the first one you're looking at because you got the other ones right. Not quite sure. Hopefully that's the case. We got the fencing plan here. Rectangular plot of farmland will be bounded on one side by a river. Well, let's color code this a little bit, shall we? Here's my little river, fancy river. And I will go some different color with a fence. And then it's got fences on the other 3 sides, right? So, oh my gosh, sorry about that. Let's make that a little smaller. That's not good. I think I was just trying to change the color. Then we got my fence. It looks like this, right? Farmland will be bounded on one side by a river and 3 sides by a single strand electric fence. With 800 meters of wire, it suppose what is the largest area you can include and what are its dimensions? So we got 800 meters of wire. So I think what I'm going to do is call that X, call that X, call that Y. Although it does not really say this, number 9. Oh yeah, it does say rectangle. Good, it's a rectangle. All right, so that means that 2x plus y must equal that 800. Pretty straightforward here. I think we're trying to maximize the area, which is just x times y. So we come up here, y is 800 minus 2x. All right, so we're going to go x. This is what we're trying to maximize, area times my y, which is 800 minus 2x. I'm going to distribute that. I get 800x minus 2x squared. Take the derivative. 800 minus 4x, set that equal to 0. 4x equals 800. X equals 200. Come back up here, which means it's 200. And then notice we got the wire, so we got 2x plus y is 800, so 200 and 200 for the x, that's 400, at least 400 for the y, right? So I think that means the dimensions of the area are 200 by 400. And the question, make sure you answer the question, was what is the largest area you can close and what are its dimensions? So there are the dimensions. And then we got 8 with 1, 2, 3, 4 zeros, I guess, meters squared. That was number 9. Number 15, next, is finding an angle. 2 sides of a triangle have lengths A and B. 2 sides of a triangle have lengths A and B. The angle between them is theta. What value of theta maximizes the triangle's area? Hint. So this is a nice little trick. 1/2 AB sine theta. This is an area. I don't know if we would have covered this in class or not. If we have, great. If not, here it is again. This is a nice little formula for the area of a triangle. In the real world, it's actually maybe the best formula. Maybe Heron's formula is the best with adding or just knowing the lengths of 3 sides. It's hard to find the height of a triangle in the real world because dropping a perpendicular is tricky. So this is nice. You just measure that angle, find the lengths of the 2 sides. So we're trying to, the question was to find the value of theta that maximizes the area. So we're trying to maximize this. A and B are just constants, so don't be fooled by this. It's really easy to be fooled by this, but A and B are just constants. It doesn't even matter what they are. They're not impacting the length of the triangle. The angle that's moving is. So we're just going to take the derivative, and that AB is a constant, so it's just going to stay there. It's just like the 1/2 is a constant. So the derivative is just the sine theta, which is the cosine theta. Set that equal to 0. That's equal to 0 when cosine theta equals 0. Which means theta equals pi over 2 or 90 degrees, which you probably would have guessed to be the area of that triangle anyway in the first place. So that's it for 9 and 15. I'll be back for the last 2, 16 and 20 in just a second.